Hello guys, so today we will do a few problems on electromagnetic waves. Only 3 problems. It is very easy and simple problems, and problem number 1 will be about the direction, okay, regarding electromagnetic waves. And number 2 is rearrangement of electromagnetic waves, electromagnetic spectrum. Okay, rearrangement. Okay, rearrangement. Number 3 will be frequency and wavelength. Frequency and wavelength. Okay, so we will do problem on direction, rearrangement, and frequency and wavelength. Okay, so the first one is about direction. Okay, so what do we mean by direction? Direction means, we know that in Electromagnetic chapter, in the first class and the second class, we have learned about electromagnetics. Electromagnetic wave are transverse wave in nature, isn't it? And propagate along axis or whatever axis, but they are perpendicular to the electric field and magnetic fields. Or we can say that electromagnetic waves are electric field, changing electric field and magnetic fields, which are always perpendicular to each other and also to the direction of propagation, isn't it? If we draw this, and let's say, okay, this is x-axis and this is also x-axis, but we can say this is negative x-axis. Okay, negative x-axis, and y-axis and negative y-axis, and we can also draw another axis which is z-axis, and this is a negative z-axis. Okay, so this is a three-dimensional and axis, and here is the origin. Now we know that if electron propagate in space, if this is like this, where this is electric field, if this is electric field, then the magnetic field is like this, we know that, which is parallel to the ground, we can say, or perpendicular to this white box. Okay, perpendicular to its magnetic field. So now we can say that E is along because up, we can say this up and down is electric field. That means it is along Y. And what about B? B, magnetic field. It is inward and outward, means towards whiteboard and towards you. Okay, so inward and outward, that means Z. Then what will be the propagations? So the propagations, we can say propagation will be along x-axis. So x-axis. Okay, and so the direction, and like this, if E is along Y and magnetic field B is along Z, that means, of course, propagation will be x-axis, isn't it? Let's check another example. Okay, now if for example, if the propagation is along z-axis, okay, in this direction, and electric field is, let's say, is x-axis, that means electric field is like the, sorry, let me draw with another color. Okay, electric field is in this way, parallel to now it is, the propagation is along Z, sorry, the propagation is along Z, and electric field, changing electric field is along, and this is That means it is x-axis. Okay, that means x-axis means parallel to the ground. Okay, parallel to the ground. Then what about B, magnetic field? It will be along y-axis. Okay, so along y-axis. Where is y-axis? So the y-axis is we know y-axis is here. That means it will be up and down, up and down, up and down. This is up. So three dimension is very difficult to draw in this kind of two-dimensional board. Okay, that means it will be up this magnetic field, whereas electric field will be parallel. Okay, parallel to this, parallel. This, if this is the axis, and up and down, this up will be down, will be magnetic field. Okay, magnetic field. So what you have to know is, if the two are already in x-axis and y-axis, another will be in the z-axis. Okay, or we can say, if another if the magnetic field is along x-axis and the propagation is along y-axis, that means automatically the electric field will be in the z-axis. Okay, so let me show you one simple question. So you can see question number 9. Which of the following pairs of space and time varying electric and magnetic field would generate plane electromagnetic wave traveling along the z direction? This is, let me point with, this is ex by ey bx. That means we have to know is z direction. The direction of the propagation will be z. Okay, and ey by ex bz and ex bz and ez bx and so ey bx d. So which one will be the correct option, correct answer? It will be, of course, it will be A. Why? Because the direction is z. That means magnetic field will not be in the z direction, or electric field will not be in the z direction. Here we have y and x and y, but here we have z. We know that according to the equation, z direction will be only the propagations. So it is not possible, and here also is not possible bz, and here is ez, electric field in z direction is not possible because the propagation will be in the z direction. So the only possible is ex by and ey bx pair. Okay, what you have to know is the one which is not included in the options, that will be the directions. If ex and by is given, that means the propagation is along z. Or if x is given and the propagation is along y, that means the magnetic field will be in the z direction. Okay, whichever is not in the option, that will be the answer. Okay, it will be the answer. So let's take a photo, and you can see here. Okay, it's along z direction. It is z direction. Oh, sorry. Okay, so this one will be only the correct option. Okay, so let us go to the next page. Let's go to the next page. Now we'll learn about a rearrangement. Rearrangement means we already know that electromagnetic waves, electromagnetic spectrum, there are 7 electromagnetic waves, isn't it, in a spectrum? Okay, number 1 is radio waves. We know that radio waves, and then microwaves, and then infrared, and then visible region, then after that ultraviolet, and after that X-ray and gamma ray, isn't it? 1 2 3 4 5 6 7. There are 7 electromagnetic waves in an electromagnetic spectrum, isn't it? Here this one have the largest wavelength, okay, but smallest frequency. Largest wavelength but smallest frequency. So the frequency is going like this. microwave is frequency is higher than radio waves, okay, and then it will go like this. Then the highest frequency is gamma ray, highest frequency, okay. However, if we arrange according to the wavelength of gamma ray is the smallest, wavelength of gamma ray is the smallest, so it goes like this, and this will be X-ray is higher, have longer wavelength than gamma rays, okay, and then ultraviolet, violet, infrared, microwaves, and radio waves, okay. Regarding wavelength, gamma rays have the smallest wavelength, whereas radio waves have the largest wavelength. Regarding frequency, radio waves have the least frequency, whereas gamma rays have the highest frequency. So we are going to arrange. There is, if I give you questions like this, arrange infrared, X-ray, and radio waves and ultraviolet rays in the order of increasing, ascending, okay, ascending order of frequency. So arrange infrared, X-ray, radio waves, ultraviolet according to ascending order of frequency. So they are not in order, okay. Right now this infrared, X-ray, radio waves, and ultraviolet are not in order. So how are we going to arrange? What will come first? Ascending means ascending greater and greater. That means we have to put the least frequency. Which one is the least frequency? Radio waves, okay. Least frequency, ascending order. For now it will be here. Next will be which one? Frequency after radio waves. Now infrared rays, okay. Radio wave, infrared, and a little bit higher frequency will be ultraviolet, okay. And next will be X-ray. In the last, X-ray, X-ray, okay. Okay, no problem. X-ray. So radio waves, infrared, ultraviolet, X-ray, okay. Now we arrange in the correct ascending order of frequency. So this and this arrow mark denotes that we know that in mathematics, less, this is radio wave is lesser and infrared is greater, okay. I hope you know. So you try to answer one more questions, okay. Let me take another page. One more questions. Try to answer one more questions. Okay. Okay, it's like this. Now arrange the given electromagnetic radiation in the descending order of the frequencies: infrared, X-rays, ultraviolet, and gamma rays. Descending means lesser and lesser. The greatest frequency will come first. The greatest frequency will come first. Then which frequency will be the first? Gamma rays will come first. Gamma will come first, and then gamma rays, then smaller and smaller. Next, this will be first, and then which one will be second? Gamma rays. X-ray will be second, isn't it? X-ray will be second, and then which one will be the next? Gamma, ultraviolet, okay, UV, and which one will be the last? Which one will be the last? Okay, this is ultraviolet, the third, and the last one will be infrared, okay, infrared. So we arrange in the descending order of the frequency. Frequencies are lesser and lesser. Infrared frequencies is the least, whereas gamma rays is the highest among this, okay. So you have to be very, very clear about the electromagnetic spectrum arrangement, okay. So this is the second problem. The third problem, okay, the third problem is frequency and wavelength. Frequency, regarding frequency and wavelength, okay. So this will be the third problem. Frequency is new, or sometimes it is F, and wavelength. Okay, so frequencies SI unit is hertz, Hz, and wavelength is in meter. Okay, so we will do some problem. Let me give you one problem. The electromagnetic frequencies, wave 1 electromagnetic frequency is given 4 into 10 to the power 14 hertz. Okay, now find out its wavelength, electromagnetic wavelength. We have to find out. So in this we have to use the formula, which is very, very important. C equal to nu lambda. Okay, so this formula is very, very important. C equal to nu lambda, where C is the speed of light, 3 into 10 to the power 8 meter per second. C equal to 3 into 10 to the power 8 meter per second. Okay, so now we are going to find out this wavelength, and this is given, and also a speed of light is given with this formula. So let me work it out. According to the formula, C equal to nu lambda, then lambda will be C by nu, where C is 3 into 10 to the power 8 meter per second, and nu is 4 into 10 to the power, is it 4? Let me check it out. Am I right? Correct. Is it 4? Yeah, 4 into 10 to the power 14. Yes, that is correct. 10 to the power 14 hertz. So let's take 1 0, so it will become 30. For dividing simplicity, we can directly divide this this 2. 3 by 4, there will be a decimal. Okay, but this will be easier, divided by 4. So now 10 to the power 7 into 10 to the power, this will go up, this will go up, and then this will go up, and then it will become minus 14. Okay, so in the next, lambda equal to 30 by 4 into 10 to the power, so 7 minus 14 will be minus 7, so minus 7. What about 30 by 4? 34. Let's do in another page. 34. 4 7s are 28, and 2 4 5s are 20. So it is 7.5, isn't it? 7.5. That means it will be 7.5 into 10 to the power minus 7. Wavelength is in meter. So this is the answer. Okay, we can work it out. Sometimes the question is coming like this. Find the wavelength of the electromagnetic waves of frequencies in free space and give it 2 applications. So here also, what will be the application for this particular wavelength? What is? Write 2 uses. Write 2 uses of this 7.5 into 10 to the power minus 7 meter. So we have to know this particular wavelength, in which region it is. So in order that you have to know very well about the frequency range and the wavelength range. Okay, so let us check the frequency range. Here you can see gamma rays, X-ray, ultraviolet, visible and infrared, microwaves and radio waves, and then the frequency range and wavelength range. So we have to check 7.5 into 10 to the power minus 7. Here is minus 7. So 7.5 will be between this 4 into 10 to the power minus 7 to 8 into 10 to the power minus 7. In between this. Okay. So in between these, our problem 7.5 into 10 to the power minus 7 will be among here visible light. Okay, visible light. So visible light. That means let's take snap. Okay. So this visible light. So we can know that it will be this visible region, isn't it? Visible region, this one. So what are the uses of a visible light? So you have to know that. So sometimes the question is coming like this, not directly. Okay, uses. Now visible weekend light. It makes things visible, isn't it? Visible light, 7 color from sunlight or from a torchlight makes things visible. Uses number 1. Uses number 2, it is used in photography, isn't it? Photography, very popular. Photography. So, and there are many more also. So write 2 uses of the given electromagnetic waves given in the problem, which is a wavelength, a particular wavelength. So a particular wavelength, this one is among visible region of light, and the uses of this is visible, it makes things visible, and it is also used in photography. Okay, so a question is coming like this. So let me give another problem. Okay, another problem. A question is can come like this. What is the wavelength of a television station which transmit vision on 500 megahertz given C equal to 3 to 10 to the power 8 meter per second? Okay, so let me work it out. So solution here, C is given 3 into 10 to the power 8 meter per second, and frequency is given 500 megahertz, and megahertz is 500. Mega means 10 to the power 6 hertz. Okay, and we have to find its wavelength. Okay, now we have a formula C equal to nu lambda, and we have to find out its wavelength. C by nu, C is 3 into 10 to the power 8, and then frequency is 500 into 10 to the power 6. Okay, and then this is 3 by 5 into 10 to the power 8. Here down is 2 zeros, another 6 zeros, that means 10 to the power 8 zeros. So we can cancel up and down. And then 3 by 5, what is 3 by 5? 3 divided by 5 means decimal will be there, and here is 0, and 5, 6 are 30, so 0.6. Therefore, wavelength, the given wavelength is 0.6. Its unit is meter, so we work it out. Okay, so we find out the answer of this given questions. Okay, what is the wavelength of television station which transmit vision on 500 megahertz given C equal to 10 to the power 8 meter per second. So here is the solution. Okay, and the most important thing in this problem is its formula. This formula is very important. Okay, this formula, C equal to nu lambda. And also you have to know about this frequency, name of electromagnetic waves, and its frequency range and wavelength range, or if you know its frequency range, you can convert it directly from the formula to the wavelength range, and how they are produced. Okay, and uses of electromagnetic waves, it's part of electromagnetic spectrum. Okay, so these are the problem which we can do. That's all for today. Thank you. And if you like, you can do 2 problems for assignment at home. You can do it yourself. Write the following radiations in a descending order of wavelength: red light, gamma rays, microwaves, radio waves. And also find the wavelength of electromagnetic waves of frequency 5 to 10 to the power 19 hertz in free space. Give its 2 applications. Okay, that's all for today. Thank you.